Hello everyone, thanks for tuning into my video today in which we're going to talk about a couple things. Briefly, we're going to talk about something called the remainder theorem, and then we will talk about solving polynomials. So first of all, the remainder theorem, it's just another way for us to find a value of a function given an independent value. Okay, so the old way of doing this, if I asked for finding the value of f of x at -2, we would simply take -2 and put that everywhere we see an x. Right, so let's see, that would give us 3 times -8 plus 4 minus 10 minus 7, so it'll be -24, and then 4 minus 10 minus 7 is -13, so that'll be -37. Hopefully I did my math right there. But another way we can do this is using synthetic substitution, which is essentially synthetic division, and our remainder should be our answer here. So if we set up synthetic division and go through our synthetic division process, hey, look at that, we get -37. So both of these are going to tell us that f of -2 is -37. So instead of actually substituting the number in to x, we can use synthetic division, and our remainder would be our answer. All right, so now let's talk about solving polynomial equations. How would we find the zeros of this function f of x without the aid of a calculator? So we're talking about something here called the rational zero test. If the polynomial f has integer coefficients, every rational zero of f has the form p over q, where p and q have no common factors other than 1. P is a factor of the constant term a sub 0, and q is a factor of the leading coefficient a sub n. What does that mean? Let's take a look at this example. Let's try this f of x function here. The factors of p are the factors of 75. Okay, so that would be positive or negative 1, 5, 15, and 75. Can you think of any more? I sure can. So let's actually go back here. I missed a couple. 3, 25, and 75. There's all of our possibilities. Okay, any number that goes into 75 evenly. Then we'll list the factors of q, which is the leading coefficient. Well, the leading coefficient is 1, so the only factor of 1 is plus or minus 1. That's it. So then what we're going to do is we're going to take all of the factors of p and divide them by all the factors of q. Now, because q is just 1, basically our rational zeros are just that. Okay? So then what you're going to do is you're going to take synthetic division, you're going to take one at a time, and we have 12 possible answers here. The hope is that at least one of those is an answer, is a solution to this problem. Okay? Is a zero to this problem. All we need is 1. Why do we only need 1? Because this is a cubic function. So if we can find 1, then we can factor it down to a quadratic function, and then we can use all the methods of solving quadratics that we learned earlier this year. So I already know the answer to this problem, but let's pretend like I don't. Let's try one. Let's say we tried 1. All right, so we have 1, -1, 13, 75. Now, we want to get 0 as our remainder. Anything but 0 means this doesn't work. So 1, 1, 0, 0, 13, 13, 88. That's bad news. That means 1 doesn't work. So what does that mean? We try a different one. Maybe let's try -1. Now again, I know that the answer, and I know -1's not going to work either, but let's try it anyway. So 1, then -2, 15, negative 15, 60. So again, we didn't get 0, so that doesn't work either. So we just keep trying them until we find one that works. So the one that is going to work here is negative 3. Let's see why that works. So 1, negative 3, negative 4, 12, 25, negative 75, and 0, and that's what we want. So now I could rewrite f of x as x plus 3 times x squared minus 4x plus 25. So I know that one answer is negative 3. What about from here? What are my answers? So that's when we could try to factor it, which this is not going to factor, which means we either have to use completing the square or we can use the quadratic formula. Just for fun here, let's use the quadratic formula. And we would get 4 plus or minus square root 16 minus 100 over 2. So that's 4 plus or minus the square root of negative 84 over 2, which is 4 plus or minus the square root of 2i root 21 over 2, which is 2 plus or minus I root 21. So our answers here are negative 3 and then our imaginary answers, but we only want to talk about the real answers here when we're talking about zeros. So we have 3 answers, but only one is real, and that would be negative 3. All right. So here's another possible answer here. Let's try this one. That's the possible rational zeros for this one. X cubed plus x plus 1. So P and Q are both 1, which means our only possible answers here are plus or minus 1. Right? It's plus or minus 1 over plus or minus 1. So it's just plus or minus 1. So we're going to try both of these. But don't forget, we learned this in our last video, that we have to put a 0 in for x squared. So 1, 1, 1, 1, 2, 2, and 3. So we didn't get 0, which means this is not an answer. So let's erase that. Now let's try negative 1. So 1, negative 1, negative 1, 1, 2, negative 2, negative 1. That's also not an answer. So what that means is there are no rational answers to this problem. Now there has to be an answer, but we don't know what that answer is. So right now, there's only one way to solve this problem, and that's by graphing it. So if you have a graphing calculator handy, we could type it into our function, into our y1 function here. So x cubed plus x plus 1. If we graph it, that's not a very good window, so let's try this again. Negative 5 to 5. Just going to take some guesses here at what our window can be. But obviously, you want to make sure we can see the x-axis here. So, yes, and there is our answer, right around there somewhere. So we can go second, calculate the 0. And we should know how to do this by now. Go just to the left of it, enter, just to the right of it, enter, and our 0 is negative 0.682. All right, so factored form, there's no way to factor it. That means our factored form is just the original function. All right, the other two answers would be imaginary, but there's really no way for us to find them mathematically with our knowledge at this point. All right, number 2. So here we have a quartic equation, which means there's 4 answers to this problem. Whether or not they're real, we don't know. Whether or not they're rational, we don't know. All right, so what our job is going to be is simply to make a PQ list. All right, so factors of negative 28 divided by factors of 1. So plus or minus 1, 2, 4, 7, 14, and 28. All right, so now again, your goal is just to start guessing. We have to find two answers that'll work for this one because this is a quartic. So if we can find two answers, then we can use our quadratic solving methods. All right, so I'm not going to waste time here guessing wrong. I do know the answers to this problem. So let's pretend like we've guessed a couple, we got them wrong. Now we're going to guess correctly. So the first one I'm going to guess is 2. It's going to be 1, -6, 3, 24, and -28. So 1, 2, -4, -8, -6, -12, 12, -24. I think I can't read my own writing. This is normal for me at this point. This is not a 2. This is supposed to be a -3. Or sorry, +3. Which would make this a -5. Make this a -10. Make this a 14. Make that a 28. And there's our 0. Okay, I knew I was doing something wrong there. I can't read my own writing. So x equals 2 is one of our answers. All right, so let me keep trying because now we only have a cubic. This is now a cubic. So right now we can say this is x minus 2 times x cubed minus 4x squared minus 5x plus 14. But that's not good enough. We can't really solve a cubic easily. So that means we should try to find one more. So now we can try more, but when we try more, we should put them into the new coefficients, not the old coefficients. So now the other answer that I know is true is -2. So let's try -2, but put them into the new coefficients, not the old ones. So 1, -2, -6, 12, 7, -14, and 0. So now I can say it's x minus 2, x plus 2, x squared minus 6x plus 7. So x equals -2 is also a solution. So now our goal is to see what can our answers from here be. Can we factor that? We cannot. The only way would be +7, +1, or -7, -1, which is not going to give us -6. So then we have to use either quadratic formula or completing the square. Let's use completing the square this time. So x squared minus 6x plus 7, add 9, subtract 9, x minus 3 squared minus 2 equals 0. Add 2 and take the square root, and add 3. So 3 plus or minus root 2 would be our other zeros. So factored form then would simply be f of x equals this right here because it doesn't factor any further than that. Okay, at this point, I would like you to stop this video and try number 3. Actually, at this point, let's just make sure we get the possible rational zeros correct for this one, and then you can try this one from here. So the rational zeros here, factors of p are 1 and 3. Factors of q are 1 and 2. So we put 1 and 3 divided by 1 and 2, and we get 8 possible rational zeros, as you can see there. Okay, so at this point, pause this video, try to find the rational zeros. All you have to do is find 1 here, because then you can factor it from there, or use the quadratic formula. So keep guessing until you find 1 rational zero, and then you can use the quadratic solving techniques to find the rest. Come back when you're done. All right, so you could have chose 1, 1/2, or -3. All of those would have worked here. I chose 1. But then when your final answers, you get those 3 as your final answers. But also, we can factor that completely into 3 binomials. All right, same thing here. Now fully try number 4 on your own. Write your rational zero possibilities. This is a quartic equation, so you got to try to find 2 by using synthetic division. Once you find 2, you'll have a quadratic left over that you can try to solve for using our quadratic solving methods. Pause the video here. Come back when you finished number 4. All right, here's the answers to number 4. This was a tricky one because for the first time here, we see that there could be a repeat answer. Okay, 2 is a repeat answer. It has multiplicity of 2 is what we would say. So 1 and 4 aren't going to work, which means the only way to do this would be to find 2 twice, and then the next part doesn't factor nicely, so we would leave our factored form like we have here. Okay, last one, number 4. Actually, this would be number 5. Find all the real zeros of this, given we know that x equals 2 is a 0. All right, so first let's write out our PQ list. So our possible answers are plus or minus 1, 2, 3, 4, 6, 12, and 24. Oh, and I missed one, and 8 as well. So we have 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 possible answers here. That's going to be a mess to try to find. But all we got to do is find 2 of these, okay? So again, I do know the answers to these, so I'm just going to go ahead and start guessing the correct answers. I know that one of the answers is positive 2. So if I use positive 2, okay, so 1, 2, 3, 6, negative 4, negative 8, negative 12, negative 24, and 0. So one of our answers is x equals 2. Hey, look at that. They told us that. And I know one of the other answers is going to be negative 3. So now I'm going to use negative 3, but remember, I'm going to use it in my new constants here. So 1, negative 3, 0, 0, negative 4, 12, 0. So I know my second answer is negative 3. And now I know that I can rewrite P of x as x minus 2, x plus 3, x squared minus 4. And if I could factor this, which I sure can, to x plus 2, x minus 2, I can get the rest of my answers, which are negative 2 and 2 again. But we don't have to write that 2 again. We already got it once. You'll got to write it again. So our 3 answers are here. 2 has multiplicity of 2. The other ones have multiplicity of 1, is what we would say. All right, now it says solve the inequality. All right, so we already got our critical points of negative 3, negative 2, and 2. It's just greater than 0, so these are going to be open circles. Okay, and we know that this has multiplicity of 2, and the other two have multiplicity of 1. So let's pick our test point here. I'm going to pick 0. If I put 0 in there, I would get positive 24 back, so positive. As I cross over 2, I'm not going to change signs. As I cross over negative 2, I do change signs. And as I cross over negative 3, I change signs again. So we want greater than or equal to 0. That happens here, here, and here. So my final answers are negative infinity to negative 3, union negative 2 to 2, union 2 to infinity. That'll do it for today's lesson on solving polynomial equations and a little bit of inequalities thrown in there at the end. Thanks as always for checking out my video, and I hope to see you again soon.